All right, so we're going to go over boxes 1 through 9 today together. The first box is congruent triangles. The definition of congruent triangles are triangles that have the same shape and the same size. Okay, so they're a copy of each other, essentially. And then let's take a look at box number 2. So box number 2 says corresponding parts. If triangle ABC is congruent to triangle XYZ, then the following parts must be congruent. I'm going to zoom in here actually. Let's highlight. So notice that A was first. Maybe not highlight, it's like too big. Okay, notice that A was first in these 3 letters and X is first in these 3 letters. Then angle A must be congruent to angle X. So the order matters. If I put A first in my triangle name, that means it's congruent to X because X is first in that triangle name. They're both first. So angle A is congruent to angle X. We also have that angle B and Y are congruent, so angle B is congruent to angle Y, and that's because they are both second. Okay, so remember, once again, the order matters. So the first is congruent to the first, the second is congruent to the second. Let's do the third. C and Z, they are both third, so angle C is congruent to angle Z. Okay, and then also, like if you were to draw this out, AB can be connected. So AB, that line segment, it will be congruent to XY, that line segment. So that side of the triangle will be congruent to that side of the triangle because these are the first 2 letters. So once again, just repeating that the order is important. I guess I could choose a different color now. That's a nice color. That's a nice color. Okay, and then we have B and C, so like the second and the third. That's going to be congruent to the second and third over here, so the YZ. So those 2 sides of the triangle are congruent. And last but not least, let's do, okay, whatever, this one. The first and the third, you can connect those 2 sides, and you can also connect the X and the Z. So AC is also congruent to XZ. Okay, so that's how the letters and the order of the letters is important. You want to remember that the order the letters are given in the congruence statement tells you which parts correspond with each other. Okay, so that's what this box is saying. So when we talk about this in math class, we tend to call it this, CPCTC, which stands for corresponding parts of congruent triangles are congruent. So we have labeled all of our corresponding parts in this box. These are all the corresponding parts. So if you have corresponding parts of congruent triangles, then those are congruent. So we just kind of abbreviate that by saying CPCTC, so that you don't have to write all of these words. Okay? So I'm going to pause here and see if any of you guys have any questions. I'll give you guys 10 seconds to either type in the chat or say something out loud. Cool, so let's go on to the next section, which is box number 4. We have something called an, oops, let me zoom in, thank you. We have something called an included angle. So the angle formed by 2 sides or the angle in between 2 sides. So over here, this is your included angle because it's in between 2 sides. So included just kind of means like in between. Similarly, we have an included side, which is the side of the triangle that the 2 angles share, or the side between the 2 angles, which means this side is our included side because it's in between 2 angles. Any questions on that one? Alrighty. So then here are the theorems that we kind of read about, or not read about, that we watched in that video. So if you missed the video because of internet issues or whatever happened, it's okay. It's posted on the Google Classroom. You just need to watch it later on today. So I'm going to briefly go over these, but not spend too much time on them because you've already seen it in the video. So box number 5 has the side theorem, which tells us if the sides of one triangle are congruent to the corresponding sides of a second triangle, then the triangles are congruent. So over here we have all 3 sides of the triangles are congruent to each other. So then these are congruent triangles. That's pretty much it. Then we have the side angle side theorem in box 6, which is abbreviated by SAS. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So let me just show you the side angle side. So it's side angle side. Okay, we are definitely having internet issues today. I can see that. Side angle side. Okay. And let's go back to the first one. This is like side, those are congruent. Side, those next ones are congruent. And then side, those are congruent. So then we have congruent triangles in these examples. Scrolling on, we have the angle side angle theorem. If 2 angles and the included side of one triangle are congruent to the 2 angles and the included side of another triangle, then the triangles are congruent. So we have angle side angle theorem. So we have to start with an angle. So those are congruent. Great. Side, the one right next to it. That's great. And then angle. Those are congruent. Great. Then we have that these 2 triangles are congruent. And by the way, you have to say that triangle ABC is congruent to triangle DEF. You cannot say ABC is congruent to triangle FDE. It is wrong because remember, according to this box, the order you say the letters matters very much. You have to label them so that the first letter corresponds to the first letter. The second letter corresponds to the second letter. The third letter corresponds to the third letter. So over here, it's not triangle FDE. You have to say like A, oops, that's kind of an ugly way to do it. A corresponds to D, B corresponds to E, and C corresponds to F. So you go ABC, triangle ABC is congruent to triangle DEF, DEF. So you have to put them in the right order. You cannot just put it in a random order like this. This is all wrong. Okay? I guess I could pause here, see if anybody has any questions. I'll give you guys 10 to 15 seconds to just speak up. All right, so let's move on to box number 8, which is angle side theorem, so AAS. So it's a similar thing. We're going to start with an angle over here. They are congruent. And then you go over to the next angle. They are also congruent. And then you go on to the side. They are congruent. And so since those 3 things are congruent in that order, then you have angle side, abbreviated by AAS. Okay? And then you can say triangle ABC is congruent to triangle DEF. All right, so let's do box number 9, which is our last box. And then I'll see if you guys have any questions. So for box number 9, there's no such thing as the angle side theorem or the side angle theorem. So unfortunately in this class, you will never get to say that in class, which is great for me because then I don't have to deal with it. So then there's no SSA either, which is just backwards of ASS. This doesn't exist. This does not prove that you have a congruent triangle. And the reason for that is, take a look. If you have an angle that's congruent, great. You have a side that's congruent, great. But there's 2 ways that you can put that third side. So I'm just going to mark those as congruent. But do you see how those two triangles are like completely different triangles? So there is no such thing as the ASS theorem. It just doesn't exist. It's just wrong, okay? So yeah, so now that we've finished off those 9 boxes, do you guys have any questions?